So this is a talk through of the first topics test in physics, which is 6.1, distance, speed, and acceleration for foundation tier. Question 1 says, two things happen when a car driver stops, does an emergency stop. The driver sees a hazard, and he thinks what to do, and then the distance traveled in this time is called the thinking distance. The driver's foot presses the brake and stops the car. What is this called? Well, this is called braking distance. So it's the mechanics of braking. Now, when we're talking about thinking distance, there are a few things that affect thinking distance. For example, if you're under the influence of alcohol or drugs, if you're extremely tired, there's also factors like distractions. So if you're on your mobile phone or if you're talking to the next person, even your age. It's all about reaction time, thinking distance there. Whereas the braking distance is all down to the mechanics of the car and the weather conditions. So weather conditions, if it's icy, if it's raining, it's all going to affect. So regardless of the time it's taking you to think, it's going to affect your braking distance as soon as you hit that pedal, and then the time it takes you to stop. So if it's wet, it's more likely to be less friction. Again, if it's icy, less friction. There's how worn your brake pads are. So a nice fresh set of brake pads will create more friction, therefore reducing the braking distance. And you've also got things like the tread on your tyre. If there's an increased tread on your tyre, then braking distance again will be decreased. So that was that question for 1 mark there. Then it comes to this graph, and it just shows how the thinking distance changes with the speed. So describe how the thinking distance changes as the speed changes. Well, for 2 marks, and this is a typical type of question you would get in an exam where it asks you to find a relationship. So as the speed changes, so does the thinking distance. So the faster that you're going, the longer it's going to take you to think about, or the time that you actually think about it will be the same, but the distance that you stop in will be longer because you're going faster, therefore it's harder to slow down. So as the speed increases, so does the thinking distance. It's a constant rate, okay? And how is feeling tired likely to affect this? Well, feeling tired is going to increase your thinking distance, so it's likely to affect it. So by going less miles per hour, or meters per second in this case, you're still going to come out with a higher thinking distance because you're tired. It takes you longer to think about it. Therefore, the time it takes you to stop is going to be more. So you're going to increase there. And I've added that line there for 1 mark. So that was question 1. For question 1C, it's just asking you to identify these graphs here. So there's car A, B, and C. Graphs show how the speed of each changes. So how fast were the cars traveling when the red lights changed to red? So you can see that if we look at the speed for all of them, they're all the same. They're all the same. And if you count these little boxes, for every 2 box is worth 1. So I've counted up, and I've said that was 13 there, 13 meters per second. After how many seconds does car A stop? Well, A stops, becomes 0 meters per second at 8 seconds. Which one of the cars, A, B, or C, stops in the shortest distance? Well, we've only got to look at the time because they're all doing the same speed. So that the one that finishes in the least amount of time is going to stop in the shortest distance, and that is graph B. How does this graph show this? Well, there's the biggest deceleration. The line is the steepest line there. On to question 2. Distance time graph shows the journey made by a cyclist. So, complete the graph using the information in the table below. So I've plotted these, so you can see for 60 seconds, 80 seconds, 100 seconds, they were all 200s. So that's what I did, 1, 2, 3. And then it starts to increase again there. So from 400 and 600 right there. And I've joined these up. Use an equation from page 2 to calculate the speed. Well, the equation that we use is distance, speed, and time. Because we're dealing with a distance, we're dealing with a time. So to calculate the speed, I cover the s. S equals d over t, which equals, now distance is 200. The time it takes is 40. So just remember that we're dealing with this bit by here. To calculate the speed during the first 40 seconds, the time is 40. There's my first 40 seconds. So the speed is 200. Distance is 200, and it comes out to be 5 meters per second. For how long was the cyclist not moving? Well, on a distance time graph, unlike a velocity time graph, if it's flat, it means that he's not moving. He's not covering any distance in this time. Not covering any distance in this time. So he stopped for 100 minus 40 seconds there, which is 60 seconds. Compare the speed of the cyclist in the first 40 seconds and the last 40 seconds. Well, I've said he's got a faster speed in the last 40 seconds because the line is steeper and he's covering more distance. If you think in 40 seconds here, he's only covering 200 meters, but in 40 seconds here, he's covering 600 minus 200. He's covering 400 meters in the same amount of time there. Give a reason, steeper line, travel further in the same amount of time. So that was 1 mark there. Now we're on to velocity time graphs, and it says, using the information in the graph, describe the motion of the bus driver in the first 70 seconds. So there's the first 70 seconds, which is all of it. I've said the initial velocity, u, there, is 5 meters per second, because that is a line, if you can see that. So he's unlike a distance time graph where that shows it to be stopped, this is meters per second, 5 meters per second at a constant rate there. And then he starts to accelerate. So he continues for 10 seconds, and then he accelerates from 10 seconds to 20 seconds, 10 seconds to 20 seconds, at a constant rate of 1.5 meters per second. How do I know it's 1.5 meters per second? Well, I've used v minus u over AT triangle, and I found my acceleration. So 20 minus 5, so that was my initial, this is my final, over how many seconds? Well, it's 10 seconds, 20 minus 10 is 10. And then I filled in the blanks, so 15 over 10 gives me 1.5 meters per second there. So I can calculate the acceleration there by using this. And then, at another constant velocity from A to B there, at 20 meters per second, for 20 seconds, so 40 minus 20 is 20. And then at 40 seconds, he decelerates at a decreasing rate. So what that means is, so the initial deceleration is quite hard, and then it sort of tails off. Now, I always use the example of Bolt crossing that finish line. He's going to maximize his speed until he crosses, and then the initial slowdown is going to be quite dramatic, but he cannot just come to a standstill. He's going to have to tail off, and he will keep running and running until he slows down and slows down even more. And then I can also calculate this deceleration by using the same formula for acceleration. So my initial velocity was 20. My final velocity is 0. So it's 0 minus 20. You're going to come out to a negative. But that's fine because it's deceleration. So A equals minus 20 over 30, which equals minus 0.67 meters per second squared, which means it's a deceleration because my initial velocity was faster than my final velocity. During the first 10 seconds, the bus travels 50 meters. Use the information to construct a distance time graph for only the first 10 seconds. So by here, we had to do we were getting marks for our scale. So 50 meters, your distance is up on the side. Your time is on the bottom. So 10 seconds only. and then it's just gonna be a nice straight line through it because he covers 50 meters in 10 seconds. To calculate distance traveled, we're going to use this formula. So again, if you weren't given the formula, it's going to be distance, because we've got a distance, we've got a time, and we've got a speed. So your speed is, oh, this is on the opposite page as well, which is quite confusing, between A and B here. So your speed between A and B is going to be 20 meters per second. And your time is going to be 40 minus 20, which is 20 seconds. So if we cover D up, it's going to be S times T, which is 20 times 20, which gives us 400 meters. And that is the end of that paper.